All right, so I'm going to walk through what you're expected to do for the Pendulum Laboratory, whether it's in class, whether you're virtual, or whether you're asynchronous. The process is still going to be the exact same, and I'm going to give you a walkthrough regardless of which category you're in, and you can just adapt that to whichever course you are currently enrolled in. First of all, I want to point out the rubric, which is the same proper laboratory rubric you guys have used for all previous labs to this point. So I don't want to waste any time going through this because I already have a video walking through everything you need to know for this. And if you are unsure what I need for anything, you can refer back to that previous video or contact me and I'll get back to you and we'll discuss it. So I'm just going to jump right into the pendulum lab and what you're going to do. So a pendulum is defined as any object that swings back and forth with a weight hanging from the end. You might know it from a clock. Here's a clock, there's the pendulum. So now that we've defined what a pendulum is, we need to discuss what the full period of any pendulum is. And hopefully you remember from last week that the period of any oscillating object, any revolving object, is the amount of time for one full wave, one full cycle, one full revolution. So in the case of a pendulum, that means it must swing back and forth. It must come all the way back to its initial position as I have it outlined here. So it's going to swing forward and it's going to swing backwards. And what that means for you is when you're using your stopwatch, you're going to start it at the beginning and then you're going to let it swing forward, swing back, and stop your stopwatch when it gets back. And hopefully that should give you a perfect period. Although I'm going to show you two tips later on that will help you get even more accurate data and prevent a little bit more error. So now whether you're doing this at home, whether you're using the virtual FET, which I'll show you how to do for those of you who want to do it completely virtually, or you're doing it through FaceTime with another group, it doesn't matter. The idea is still the same. You still need to collect 10 data points, which means if you're testing how the color affects the period of a pendulum, which has been my example because it's something that most likely will not affect the period of a pendulum, you would do 10 different colors. So your data table would have two columns, color and period. And obviously it's not likely to affect the period unless it absorbs some extra heat, which gives it some extra swing, but then it would also be pushed by that extra heat as it's coming back. So there's really no likelihood that that would make an effect, but I'm going to use it for this example. I would choose black, blue, green, orange, yellow, green, blue, indigo, violet. I would get 10 colors. And then I would measure the period for all 10 of those. And I'm going to go ahead and show you a couple of tricks to help make this a little bit easier for you. And then I'll show you, for you asynchronous students or virtual students that want to do it on your own, how you can do it. But I don't think that the online simulation is necessary for anybody. Because again, a pendulum is any swinging object with any weight hanging from the end of it. So you could take a string, hang it from a doorway, and tie any object to the end of it. If you were doing weight, you would do 10 different weighted objects. You could use a kitchen scale to weigh them if you have one to try to get a more accurate weight. Or if you're testing the length, you could just use 10 different lengths of string or start with one long one and then cut it progressively shorter so you can get 10 different lengths. Or you can always test the angle and just pull it back to a different angle each time. And then you'll get your 10 different periods, which you can plug into the data. And now that we've discussed that, I'm going to show you how the simulation works if you do prefer to use a simulation, which is more accurate, it's more correct, but I feel that it fails in showing that the errors that occur when you do it in the real world. You don't get to experience air resistance. You don't get to experience friction. And those things matter. There's no experience in real life that doesn't have at least friction and realistically some sort of air resistance too. So to pretend that they don't exist, I feel is unfair. But I will show you the simulation for those of you who absolutely cannot get it set up to work in your house and you want to do it that way. So here's what the FET simulation looks like, and I will post this link in with the post. There's a couple of things to pay attention to. Number one, to get it to swing, you just pull it to the left and release it. And if you want to, you can add a slow motion feature, and that actually will not change your stopwatch. So the stopwatch slows down with it. I don't see why you would need to do that, so I'm going to put it back up to normal pace. So we can stop this, reset it, and again, I'm going to wait until it's all the way to the left over here or all the way to the right before starting my period. So I'm going to wait till it gets to the left and start and stop. And that took about 1.67 seconds. Now, whatever your variable is that you're testing, you can change over here. If your variable is length, you can change the length over on the right hand side. If you're doing the gravity, you can change the gravity. Or you can change the angle that you release it from. Or the other big one that we discussed is you can change the mass. So you can increase and decrease the mass to meet your needs, depending on what your one variable is. But keep in mind, you should only have one variable that you're testing at a time, whether that's mass or length or angle or gravity in the case of the simulation. That is one of the benefits of the simulation, is you can test something that you normally would not be able to test. So you feel free to play around with this, get it to work, and angle is actually super great with this too, because you have that protractor all the way up at the top that as you drag it, you can see it reads the angle right up here. It'll tell you what angle you've pulled it to the left to and released it at. So I have a 52-degree angle, and I can measure the period of that angle. So I hope that helps with those of you who want this simulation and want to use this instead of setting something up in your house. Although I think there's a lot of fun in testing this in the real world and seeing the effects of friction and sources of error. So now that we've gone through every part of this, I'm going to show you two tricks that work with both the simulation and in the real world to help you get more accurate data and cut down on some of the error that's involved with this lab. So tip number one, while you're measuring the time, don't release it at the same time you start the timer. It throws you off a little bit. You get 2.3 seconds, which is probably pretty good since I'm the person touching the stopwatch and doing it, but it takes a little bit of fiddling. Because it's periodic motion and it takes the same amount of time every oscillation, every wave, then what I'm going to do is I'm going to let it swing freely once, and I'm not going to start the stopwatch until it reaches the apex and then it comes back. 2.5. So I think I'm probably getting a little bit more accurate, but I can do even better. Because it takes the same amount of time for every oscillation, I'm actually going to let it do 3 oscillations, and then I'm going to divide that amount of time by 3 so I can figure out the time for 1 oscillation, while also not starting my stopwatch until it has swung 1 time. So I'm going to let it go and start it now. 1, 2, and 3. 7.9. So if I take that 7.9 seconds divided by 3, we're going to find that the time is 2.63 seconds, which should be a much more accurate period of time. It cuts down on the sources of error. So if your timing is off by a little bit, it'll help significantly cut down on that. I hope that helps. Thanks. Thank you, Joseph. That was very helpful. And I hope that was helpful for you guys as well. I hope that cleared up how to collect your data, what kind of data you're supposed to be collecting, and using that data, going back to your rubric and the previous video I have walking you guys through how to create a proper laboratory report. I hope you can use those in conjunction to put together a solid lab and figure out what variables do affect the period of a pendulum and which ones don't. I hope you guys have a great day, and if you have any questions, please don't hesitate to let me know. Thanks. Bye.